Hello and welcome to this video. My name is David Thorne. This is now the third video in my Python Sets for Beginners series. And in this video we're going to take an even deeper dive into understanding of sets. Now if you have watched the other videos, or the first and second video, well done. You should really give yourself a pat on the back for taking this much interest into sets. I love sets. I love set theory, and so far it's been a pleasure doing this video, and it's been a pleasure learning about small details to make all these examples. So with that said, let's get started. All right. Now I don't know how long this video is going to be, but I'm going to try and go through it as deep as possible. All right, because if you are watching this video, you really want to learn. So let's try and battle through this together. We are now going to be creating a set one, as we know, and we're then going to be using the set update to update set one to add 1, 2, and 3 to this one set. All right, we're now going to create a second set of 3, 4, and 5. Now, we now know that we have two sets, all right? And we're going to print out set 1 and set 2. And you see here set 1 and set 2, nice and simple. Now we're going to create a copy of set 1. And we are then going to say copy symmetric difference update. Now the symmetric difference of copy and set 2. So remember, copy is set 1. So we know we got 1, 2, and 3, and set 2 is 3, 4, and 5. So the symmetric difference is we know that we've got 3 and 3 in each of them. So the difference is 1 and 2 and 4 and 5 on each side. So we can see here we're printing out copies 1, 2, and 4, and 5 because they are symmetric on 3. They both have 3. So that's not a difference. That is the symmetric part of it. And symmetric difference is going to update, which means it's going to remove what that's not the difference. So it's going to update copy to be the difference rather than to be the full set. And if we now print again set 1, you see we get 1, 2, and 3, which means set 1 has not been affected by this because we made a copy of it. Otherwise, set 1 would be. But you see that copy, we make a copy of set 1, right? But then copy actually has even more items added to it because it has items from set 2 that are not contained in set 1, right? But it removes items too. So it's I just want to go through this. When you would use it and why you would use it, I'm not quite 100% certain for this one example, but that's how you use it. All right, let's move on. So now we're going to check in if sets are disjointed, right, or disjoints. So we have set 1, which has 1, 2, and 3, the elements 1, 2, and 3 in it. And set 2 has the elements 4, 5, and 6. And so let's just read that returns true if two sets have a null intersection. Now, in this sense, they don't intersect with one another because if set 2 had 3 in it, they would both intersect at 3. So this means that it does have. So return true if two sets have a null intersection. Their intersection is null because there isn't something that's there. Yeah, they don't have an intersection, all right? So we can see that if we print here are disjoints. They do not connect together, all right? They don't come anywhere near. If they were Venn diagrams, they wouldn't overlap, is what it's saying. Now, if we make a copy of set 1 and say set 1a, and now let's add 4 to it, all right? And now we say set 1a, is it disjoint to set 2? And when we do this, it now says false because they are joined, right? They do intersect with one another at 4. Because we added 4 to it. So that's why we know that if is disjoints true would mean that they don't intersect, all right? But is disjoint false? That means that they can be connected, all right? They do have matching items in the sets. So let's move on. Now, using set as a stack, last in, first out. And this, once again, is another red herring, all right? And if you see people asking you that we should use a set as a stack, they got a little bit confused about it, because you can use a list as a stack, but a set, remember, is unordered. So it doesn't matter which order you add these items to it. You could add C, then A, then B. It just doesn't matter. And stack.pop is going to pop any one of those items in there. So the first time it could pop C, then it could pop A, then it could pop B, and it could be in any order whatsoever. So don't think about sets as stacks. They are unordered, distinct items that have no order, and that's why it's unordered, all right? So don't be misled by this. If you want to do stacks, don't make them synonymous to sets, because they're not, all right? Let's move on. And so converting a string into a set of characters. So this is another key thing, is to be able to take a string of characters and to know that you get all of the distinct characters or symbols in there as well. And we've got hello here, and as we can see that we've got two L's in it. So when we create a set from my string, or the hello, we know that we're going to get H, E, L and O are the only characters in it, and the order of it is going to be of no relevance, all right? They could be in any order whatsoever. So there's a whole bunch of different permutations of what this order could be, and that's why I'm saying, you know, this just could go on until we've got all permutations of it. Yeah, and notice that it only contains a single L, all right? Because they've got to contain distinct items. Now, if you wanted to have all of those characters in there, then you would want to use a list instead. This is the key difference, all right? When to use a list and when to use a set. Okay, creating a set from a tuple. Now this goes exactly the same, is that if we got a tuple and we're only going to be using their keys in this sense, all right? So because they don't have any keys, the values are the keys. We could have non-distinct items here, like 5, but that would still make it the distinct. It doesn't really change anything here whatsoever, all right? Now, sets with mixed data types. Sets just don't care what data type it is in Python, all right? But what's important here is that hello is only going to be added once. Now in this series, it's a string that's going to be added, all right? So we're not going to be starting to separate the strings into their own characters, but the duplicates are obviously not going to be entered. And we can see here 1, hello, and then a tuple, and then 5 is going to be added to it, all right? Now finding the max and min values in a set. Now this could be super interesting for you, is that if you have an input of, you know, let's just call it 10,000 people, all with their ages, and you know you have a list of 10,000 ages, and now you want to turn that into a set. Well, now you know that you would have all distinct ages there, and then you could say what's the max age and what's the min age. This is the difference in is a list. You would have to iterate through all of them, but there are clever ways of doing this using the max and the min function. So let the implementation of the language do it for you in the most efficient way, rather than having a list where it's got to search through it in some form of searching algorithm and so on. Anyway, we see that 8 and 1 here, but there's ways and means of checking this efficiently and so on. So now set union using operator, sorry. So now we have set 1 as 1, 2 and 3. So we have elements of 1, 2 and 3. Then we have set 2 of elements of 3, 4 and 5. So we know that a union of set 1 and 2 would be 1, 2, 3, 4 and 5, right? So we can do this with the pipe symbol, and so we would say then, hey, I want you to union set 1 and 2, And for simplicity, I've added, or for demonstration purposes, I've added 6, 3 and 1 here. Now, we know that 1's going to be ignored because it's there already. We know 3 is going to be ignored because it's already in the set. And obviously this 3 is going to be ignored because it's in the set already. And then we're piping it again to A and C just to show you the data types. It just doesn't matter. And when we print the union set out, remember, order doesn't matter. We get 1, 2, 3, 4, 5 and 6 and then A and C. It could be in any permutation of this here. So it's another easy way of unioning, of creating a new set. So remember, this is a new set. So yeah. Anyway, so this would be if you had, say, like 10 groups of people and you had all of their ages of that 10 groups, and then you could pump it into a union set and then do the min and max for it as well there, all right? Let's come to the 9th one. Okay, set intersection using operator. It's the same thing once again, but rather than the pipe, we're going to use the ampersand sign, and it's going to do exactly the same thing. So 1, 2 and 3, and 3, 4 and 5. We see here that set 1 and 2, they intersect at 3, all right? So come doing this, there's only going to be a 3 in there. And then the 3, 5 and 1, well, once this is done, then there's only going to be 3 in the set. So only 3 is going to come here. And then we do it again. There's not a 2 and there's not a 5 in the sets. So there's only 3. So there's only going to be 3 here. Remember, this is going from left to right. So this is going to be intersected first. Then it's going to add this and then add this. All right. So it's another quick way of doing this. And the final one is set difference using operator. So we can see here set 1 has 1, 2 and 3, set 2, 3, 4 and 5. And I've added the set of 1 all the way through to 9. And we can minus. So it's basically just removing 1, 2 and 3 from this one set. So it's going to be left with 4, 5, 6, 7, 8 and 9. And then we're removing set 2 from it. So we're removing 3, 4, 5 as well. So it's left with 6, 7, 8 and 9. And then finally we're removing 1. So we can see here that we're left with 8, 9, 6 and 7. And the output here is random. Okay, so when I put it here, it was because it was random anyway. All right. There we go. So this is now an even deeper understanding of sets. And I've really enjoyed doing this, to be honest with you. And I did make another 10 examples of how about using sets and how efficient they are in memory, but I'm not sure whether or not I'm going to publish it, or I'm not sure whether I'm going to make a video of it. But if you are interested in digging even deeper, then please let me know in the comments below, and I will extend it as well. And if there's a good amount of feedback on that next video as well, I'll try and extend it even further, because this video series, it can nicely move into set theory, and we can literally get the foundations of set theory just using Python. All right, and it helps for many other areas in Python too. And just understanding set theory helps you in nearly every programming language, and it helps you in mathematics as well, and then on physics and so on. Anyway, with that said, if you do have any comments or any feedback, please feel free to put them in the comment section below, positive or negative. I will still read and respect every single one of them, and I will answer all of them too. If you do feel like you liked it and you want to like it, please, it helps other people to find these videos, all right? It isn't about me. Think about the other people that maybe would find this video interesting. If you thought if you thought it was interesting, maybe they will find it interesting too. And so on. So with that said, thank you very much for watching all the way through to the end. You really are important to me, and there'll be a video on the screen right now for you to watch another video that I may recommend to you. Thanks very much. Ciao, ciao. Goodbye.